Good. Now, so what I have on this desk are three different generations of PLC. I'll start with this one. Hmm? This is the S7300. I don't know if you can see this very clearly. It's written S7300. This is one of the major S7. This is like the first S7 series PLC from Siemens. Now, what you see here, this one alone is the S7300. This is the PLC on its own. I'll show you some things. In front of it, you see it has a switch. Let me use this. It has a switch. It has run, stop, and reset. So in those days, you can switch it when you're in front of a PLC. You have to go there physically to switch it to stop or to run. It has a memory card slot. So this is how the memory card looks. It's a Siemens type of memory card, so not all memory cards will work on it. This is probably a Siemens memory card. It has so many indicators on it to show you what the states, LED to show you the states of the system. And then in here, you can see connectors. So we call this DP port, decentralized peripheral port. Now, the first set of PLCs that came out came with these ones. And for you to connect to the PLC to program it, you need to have a specific, let me say, connector to connect to this. You connect to this and then you connect to your laptop before you can have access to this PLC. Some of this PLC also have DP ports and then RJ45 ports. This particular one does not have RJ45 ports. And if you can see the name here, it says CPU 315 2DP. So this is the 2DP. 1, 2. That's the 2DP. Now, if you see another PLC that shows 2PN, PN is then this Ethernet port. So what you see beside it here now, what I'm showing you is not the PLC. This is a communication processor, a CP. I connected this to this guy because I do not have this connector anymore and I want to communicate with this PLC. So I have to go in through Ethernet cable. So this Ethernet connection from here goes to my laptop, and then because these guys are connected on the back using this back pane, there is communication between them. And this PLC has already been configured. It has been configured to allow me access it through this CP. If that configuration did not exist, I will not be able to access this PLC through this CP. Now you understand the basic thing I have here. I have a PLC that has DP ports. I don't have these connectors anymore. So this PLC is configured with the CP connected with the back pane, and I can communicate with this PLC using the CP. Now you see some cables here. This is 24 volt cabling that I did, and there is the L plus and then the 0. So in control, we use specific cable types to differentiate between your control cables. Complete this differs now. Please note this. This varies location by location. In Europe, this is basically what we use. Europe and Nigeria, some things like that. In America, it might be completely different. In North America, which is America, Canada, might be completely different. In Asia, might be completely different. So these color codings, you also need to know it based on the region and industry that you're working. The complete blue cable represents plus 24 volts, and the blue and white is the zero ground. You can see that I connected it here, and I also looped the power to the CM module, and that's how this can function. So that's the CP300 series. I'll take this away. Now there is the S7 1200. Now apart from the CP S7 300 series, there's S7 400 series. I don't have that here. I can check online to show you a picture of that. But this is S7 1200, which is similar to S7 1500. However, this is a limited version of it, which means it's not as powerful as S7 300, S7 400, S7 1500. In this case, you can see the PN is already there directly. This is one of the modular, is it modular? The integrated PLCs that we talked about, which means everything is already inside of it, not expandable. This is the connection for the PN. This is the Ethernet connection. Here you see 24 volts output. I hope you can see clearly. Okay, now you can. This is 24-volt output connection. So in case I program something on this PLC and I want to control some things, this is where I will connect the cables. Here you have analog inputs. Yes, analog inputs. You have 24 volts output, and then you have 24-volt inputs. So I can power this guy using this input. I can send 24-volt output from here, and I can set 24-volt input from here. For example, if I want to connect a switch for control, I'll put it on the input side. You can also see that this guy has a memory card as well, and you see that it's completely different from the one I showed you earlier, because that one was like the first generation of CPUs. It also has its own LEDs, run, stop, error, maintenance, and then it has LEDs to show the input and output. Here, you don't have a physical stop start, so you have to stop start it through the software. You understand? You don't have a physical stop start switch, so you have to start it through the software. And the main one, which is the biggest series of the Siemens PLC, is the S7 1500 series. So there are different models to this. There is the small, there is the big, there is different types of it. This is one of them. Right here you can see CPU 1515 2PN. So it tells you that this PLC has two Profinet or two Ethernet ports if you want to directly interpret it that way. Now, PN does not mean the physical port itself. It only means the networking ports. So it means that you can network this PLC using two different ports. On this PLC itself, you see it has three ports. 1, 2, 3, right? However, two out of those three ports are under one network, and then one of those ports is under another network, which means you can program these ports in two different ways. For example, one can have the address 192.168.0.1, and then two others can have similar address. For example, 192.169.201.1, 192.169.201.2. They are on the same range. That networking is also a completely different topic. Here, you see the memory card here. This is where the memory card slot is. This is similar to the one I just showed you earlier on the S7 200 because they are both on the same similar range. It has the power connection here where you connect the power, and then it has the human interface, which is the HMI. It has a small HMI on here. On this HMI, you can see so many things going on the PLC. You can see diagnostics. You can see so many things. You can also see configuration. You can configure some things on it using all of these buttons. You can see that on this PLC, you have the run, you have the stop, you have the OK, you have the X, which means this one has a physical button to run or stop the PLC. You can also do that from the software, but you can also do that on the PLC itself. Now, if you want to add a module to this guy, this is the back, right? and then you need a back pin, like I explained. And this is how the back pin for this one particularly looks like. Just like I was showing on the website some minutes ago, where you can expand this guy. So for example, if the power supply, for example, if this is a power supply, um, if this is a power supply on the zero part of the PLC, zero slot, one slot, it means we can extend this PLC to the right. For extend this PLC, we need something like a back pin, which connects power and communication. So in this case, you see these connectors. So if I plug this now to the PLC, you see, I can put in something here. In this case, I have beside me here a communication module, which looks like this. This is a communication module. This is it. It's just a module that has Ethernet port. So for example, I want to add one extra network layer. So for example, let me go back to our first discussion today, where we talked about this. So let me bring it back on the screen, where we talked about this here. So for example, this control cabinet, we have this PLC inside of it. And then we have communication cable going to the filling machine, communication cable going to the conveyor, communication cable going to HMI. From this PLC, using those three ports that we have on the PLC. However, we want to connect to the IT network, and the IT network is on a separate network. Then we need this kind of module, this one, because this is our local network, and then we want to go to the IT network. That's when we need something like this, a communication module like this, which means this guy will be programmed to be on the IT network range. If we connect this now, it's sitting. So now this is how it looks at the back. It's sitting together. And then you can connect from the PLC to the HMI to the whatever system you're controlling. And then from this communication module, you can connect to another network. I hope uh, my explanation is understood. Do you have questions at this point? Okay. If no questions, then in this PLC now, I haven't shown you any input and output module. But before I go there, you can already see the similarities between these two devices now. Here I showed you a PLC and I showed you a communication module, right? And here I've also shown you a PLC, I've shown you a communication module. You see that these two things are basically the same, but doing two different things, right? In this case, I use this to connect to my laptop. I can also use it to connect to another network. In this case, I connect my laptop from the PLC, and then I use the connection here, which is on the CP, on the communication module, to connect to another network. Now, usually we have something like this, a switch, usually. So this switch is where all those cables that I'm talking about go to, because you don't just bring the cables coming from, let me say, IT network or from the filling machine, from the conveyor, directly on the PLC, right? You want to put it into somewhere where everybody can access easily. So in the middle of all of this, you usually have a switch. This is a switch. It's called a scalan switch. This is designed by Siemens, of course. You can use whatever switch based on whatever industry you're in, right? Based on whatever systems your your networking systems allow. So this is a switch, and on this switch is where we do connection between systems and systems. So for example, if this controller if this controller now, this one is the, let me say, the filling machine controller, and then this controller is, for example, controlling the conveyor, right? So these are two different controllers, but they have to communicate with each other because you want to pass some data between them. Then it means you take a networking cable, it goes from this guy, and then you put it on the switch, and then you go from this guy, you put it on the switch. Do you understand? And then this switch is where the communication between both of them happen, or with any other system. So you get the idea. So communication comes from this guy to this guy, communication comes from this guy to this guy, and then from this guy to another guy. Even you as a programmer will connect to this guy. Now if you connect to this one, to your laptop, you then have access to both PLCs because both of them connect to this guy. So we're going briefly into networkings now, but I just wanted you to understand that part. Now, we usually have I/O modules, which usually sits beside the PLC. In this case, you can see it here. So this is a PLC, just like I was showing you. This is a power module, this is the PLC, and here you see these blue cables that are connecting here. This is like an input and output module. You can already see these LEDs. So these ones are integrated, these are modular, these are connected beside the PLC. Like I was showing you in the case of this CM, instead of this CM, it could also be an input module that I'm connecting here. It could also be an output module. It could be any type of module as I have this back pin. You understand? However, it means that wherever that I am connecting, if I put the input module here, it means that because in engineering you want to save costs. So one of the ways by which you save cost is to reduce the distance of cables, right? So if this machine, for example, this controller is controlling a machine and I need to connect these guys to the input of this PLC. It means I need to run some cables from here to here if this is an input module or output module. Depending on how far this guy is, depends on how far my cable would be, how long my cable would be. In many cases, you have your input module here because what you want to connect are close to the PLC. So maybe this PLC is in this cabinet like we drew earlier. For example, the PLC is in this cabinet and then you have some relays here. So they are in the same cabinet, so they are not so far apart. Then you have this kind of system. So the cables just go directly from the PLC straight to the devices they're connected. However, like we explained before, so for example, this PLC is sitting in MyCom shed now. The PLC is in MyCom shed, and you want to control a switch in Professor Ojo's office. You can see that distance. It means the switch is there, and your input and output module is in this cabinet in MyCom shed. It means you have to run a long cable with 24 volts from that point to the MyCom shed. There will be a power loss along the way, wouldn't it? There will be interference along the way, wouldn't it? In that case, in control engineering, we introduce something that we call remote I/O, remote input and output. So what does it mean? This is it. It means that there is an I/O, there is an input and output module sitting far away from the PLC itself. So the PLC does not need to have integrated I/O sitting beside it. The PLC can sit anywhere, and then the I/O system, the input and output modules, can sit anywhere else. The only thing that will connect them are Ethernet cables. So now I can connect this Ethernet cable to this guy, connect the Ethernet cable to the PLC, and they can be anywhere as long as I meet the requirement of this distance, which is usually in many cases 100 meters. If you go beyond 100 meters, then need a repeater for Ethernet. But in many cases, maybe you use fiber optics. I have a fiber optic module for this, so that you can go 1 kilometer, 2 kilometer far away. But just understand the basics. Now, this guy can sit in Professor Ojo's office, and this guy can sit somewhere else. I can connect the switches directly on this guy, and the PLC would be able to read all of this input via this cable. I don't need to run all these cables to the PLC anymore. I don't need to run this way. I can directly connect them here, and I can monitor this PLC from anywhere, and I can see what's going on there. Now, this module in itself is called a remote I/O module. You can see it has its own power. It powers this guy. A 24-volt power is supposed to come in here itself. This one is connected to this. So instead of back pane, this one has a side pane. You see? So if I connect this together, then they can communicate. If I want to add another one, this, I can add it to this. And there are different types of modules that you can add to it. This as well. At the end of the line, there is what we call the end line. This one. This is the one that ends the line. That tells the system, okay, this is the last module on the line. There are different types as well. So here you see a DI, a digital input module. Here there is a DO, digital output module. This is a analog input module, analog output module. You can also have communication module, different modules. So you can extend this on site. You can extend this where the cables are connected, where the systems are, while you use one cable to bring everything to the PLC, wherever the PLC is sitting. That way, you've reduced a lot of cost, you've reduced a lot of maintenance, you've reduced a lot of interference, things like that. So it depends on whatever your system needs as an engineer. This is how you think. If I need all my cables to be in one place, if my input and output devices are not far away from where my controller is, then you go for the devices that sit beside the controller. If your input and output devices are far away from your controller, then you go for remote IOs. And this is how we design in engineering before we start programming. So this is what I wanted to share with you today. If you have some questions, please, let's discuss them. So if you walk into any interview room now, you should be able to explain some basics, right? It doesn't matter what kind of PLC is put in front of you, either Siemens, Allen Bradley, whatever. They all operate within the same logic, same. Might be different type of PLCs, might be different type of switches. Basically, everything is similar. So, do you have any question?